Welcome back. Let's talk about passed by reference versus passed by value to finish our discussion about JavaScript types. Now, in the previous video, I said that primitive types are immutable. What does that mean? Well, it means that we can't really change them. In order to change them, we need to completely remove the primitive type. And let's say if variable a equals 5, well, in order for me to change what that 5 value is, I have to literally move it from memory and create something new, like a equals 10. I can't really modify it, just something new gets created. And primitive types are exactly like that. When I assign variable a to 5, somewhere in memory, variable a is going to contain and reference the value 5. If I do variable b equals to, let's say 10, again, same thing. And they don't really know of each other's existence. This is what we call pass by value. Objects, on the other hand, are what we call pass by reference. Let's write some code to figure out what this really means. If I do variable a equals to 5, and then I do variable b equals to 10, well, a now has an address of where this primitive value 5 sits in memory. And same with b. b has an address of where the primitive value 10 sits in memory. What if I do variable b equals to a? What happens then? Remember, primitive types, they're passed by value. When we do pass by value, well, what if I do something like b++ here? So that is add 1 to b. If I console.log a, I have 5. And if I console.log b, I have 6. And this is because of pass by value. All I did, or all the JavaScript engine did, was copy the primitive type value 5 as if I was doing b equals 5, so that now b has a reference to the value primitive type 5. All we did was copy the value. So looking at this diagram should make sense. Anytime, even though we did b equals to a, we simply copied the value and put it into a new memory space in our machine. Remember our memory heap or our stack where we store information? We just simply made a copy. They don't really have any connection whatsoever. And that's what pass by value means. Pass by value simply means we copy the value and we create that value somewhere else in memory. Now let's see how objects are different. Unlike what we had before, or let's keep this here for now, just so you can see. If I create an object, let's say object 1, and object 1 has name of Yao, and let's say this is a user that also has a password with 123 as the password, super secure, I know. And we're also going to create another object, let object 2, and this is going to be, well, we can just copy the first object. So object 2 and object 1 should be the same, right? But what if I go ahead and with object 2, I change password to equal easy peasy? What will happen then? If I console.log object 1, and I also console log object 2, and I run, whoa, what just happened? Password has been changed. Both object 1's password and object 2's password were updated by doing this. And this is due to pass by reference. You see, objects in JavaScript are stored in memory and are passed by reference, which means that we don't copy the values like we did with primitive types. We simply, when we assigned object 1 to object 2, we simply said, hey, this is where the object is in memory. If we go back to the code, object 1 and object 2 are both pointing somewhere in memory, we don't know where, somewhere in the memory heap, to a shelf that contains this information. So all I did by saying object 2 equals object 1 is, hey, this is, let's say, the address in memory of wherever this is located. So that what that means is when I change object.password like this, I'm saying, well, change password on this object in memory that also object 1 is pointing to. It's referencing. That's where pass by reference comes from. Now, why do you think that's a good idea? Let's think about this. Why is this good? I mean, it's kind of nice, right? Because by just having one object here, we're saving space in memory. We're not copying and cloning the object, creating multiple versions. We can simply save memory, reference just one location, instead of just loading up our memory heap. But why might this also be bad? Well, because unlike a primitive type, we might have this issue where by mistake, somebody else changes a property on that referenced object. So this is something that we need to be careful of. Let's do another example. And just to prove, like I said before, that arrays are simply objects, let's try this with an array. If I do variable c, and this variable c has 1, 2, 3, 4, 5, and then variable d is equal to c, and then finally we'll say d.push some giant number. I want to make sure it's a number, not a string. If I console log c, or let's console log d first, and I run this, I see that, yep, we modified the array. But because arrays are objects, they're passed by reference, c should also have changed, right? If I console log c and I run, yep, c has also changed as well. We notice something here, right? This is good. We're saving memory. We're not just constantly copying things. Imagine if C was a massive, massive object. If we're copying to different parts of the code every time, well, this would create a lot of memory. But then there are times where maybe we do want to clone an object, copy it, so that we don't modify it like this. How can we do that? Well, with something like an array, there's different ways of doing it, but I can simply do array, an empty array, and then do the concat method, which pushes whatever I have in C into this empty array. So that when I run here, you see that C is still the same, but if I go to D, I have a new array. It's cloned an array. Objects are a little bit more difficult. Let's say we had an object that equals A1, let's say B is 2. That's a little confusing. Let's do AA, and then B, B, and then finally C equals to C. And this object, I want to copy. I want to have this piece of code, this object, in a different location in memory. How can we do that? Well, I can't do another object like this because it's simply going to pass by reference, and we're still going to be referencing the same object. Instead, we can clone an object by doing something like this. Object.assign. And in here, the first parameter is the object to copy to, which is an empty object. And then what is the source? So that is from which to copy the properties. So in my case, it'll be the object. So that now, if I change, let's say object A, or let's do object C to equal 5. If I console.log the clone object and I run, oh, I made a little bit of mistake. Let's see here. Oh, I've had a semicolon instead of a comma. There we go. If I run this, look at that. The cloned object was not affected at all, even though we changed C to be 5. Remember, if we didn't do this, we didn't clone it, and we just did object, that would have been passed by reference, and we would see the change that we saw in the original object. But because of object.assign, we are able to clone the object. Very cool. There's also another way of doing it, and that is using the spread operator. I can do let clone2 equal object, or not really, we just create an object and then do ... and then the object. Nice and clean. And this is a new feature that we got in the JavaScript language, which is really, really nice. And once again, if I run this code, I see that clone hasn't been modified. And if I do clone2, that hasn't been modified either. Just for reference, I'll add the original object as well to see that indeed it is different than what we had before. Awesome. So cloning is great. But let me ask you this. What do you think will happen with the code that we have if we have an object inside an object? For example, if C, instead of just being a string, is another pass by reference object that, let's say, has deep as a property. And this deep is going to equal try and copy me. I hope that makes sense. Let me adjust the indentation here so you see it better as to what is happening. So what happens here? We have an object that is referenced somewhere in memory. And inside of that object, there's, again, another pointer to another place in memory that references this object. Let's run this code. Well, nothing has changed, right? I mean, C has obviously changed, and well, that's something that we already saw before. But what if I change D this time around instead of C? What if I do object.c.deep? And deep is now going to say, ha ha ha. What do you think will happen here? Let's run this code. And oh no, we cloned everything, but it got overwritten. I thought we cloned everything. What happened here? Remember, each object gets passed by reference. So although we cloned the object, the initial object, this is what we call a shallow clone. It cloned the first level. So that is the memory address in this object. But within this object, there was another address to another object. So again, remember, this is just another address that we had someplace in memory. And this address, well, it never changed. It always referenced this object. So this is shallow cloning, where we can only clone the first layer. That's a big problem, right? How can we do deep cloning? And the way we can do this is, well, a little funky. We use JSON. We say let superclone. And we're going to use the JSON.parse method. And this is beyond the scope of the course. You can read up on what JSON parse does. But this JSON object is going to say JSON.stringify. Let's make this a little bit bigger. There you go. We're going to stringify, that is, turn everything in here into a string. And then once we turn everything into a string, we're going to parse it and turn that string back into an object. So that if I do superclone now, at the bottom here, let's do superclone, and I run. Look at that. Try and copy me. Superclone, let's make this a little bit smaller. There you go. Superclone version did a deep clone of the object. Very, very cool. Now, before I end this video, I hope pass by reference and pass by value makes sense to you. Now, I do want to give you a bit of a warning. However, if you're doing a deep clone, well, you should be careful because this can have some performance implications. If this object was extremely deep, a massive object, it's going to take a long time to clone everything, right? So you won't see this out in the wild too much. If you're cloning objects like this, there's most likely some other ways that you should be doing things. But I wanted to show you the idea of pass by reference, the idea of shallow cloning, deep cloning, and some of the ways that we can use objects to get the desired output. All right, I hope that was fun. I'll see you in the next video.